Imagine checking the time right now. Takes about half a second. Glance at your phone, your watch, a wall clock. Done. Now imagine there's no clock anywhere on Earth. No watch, no phone, not even a mechanical gear in existence yet. That was reality for the ancient Egyptians, and yet they still managed to divide the day into hours, track entire years with impressive accuracy, and even predict one of the most important natural events in their world months in advance. So how do you measure something as invisible as time with absolutely no modern technology? Let's find out. Here's where it all starts, with the most obvious clock available: the sun. As it moves across the sky, it casts a shadow that shifts position and length throughout the day. Early Egyptians noticed this pattern and did something clever. They started marking it. A simple vertical stick, called a gnomon, planted in the ground, would cast a shadow that moved predictably. Mark where the shadow fell at different points, and suddenly you have a rough way to divide the day into sections. This eventually evolved into more refined shadow clocks, flat devices with marked segments, read simply by checking where a shadow landed. Compare that to today, where checking time takes zero thought and zero sunlight. Egyptians needed clear skies and daylight just to know it was roughly midday. Which raises an obvious problem. What happened when the sun went down? Here's a genuinely impressive solution. If the sun couldn't help at night, the stars could. Egyptian priests studied the sky closely enough to identify specific stars, called deacons, that rose at predictable, evenly spaced intervals throughout the night. By tracking which deacon star had just risen, trained observers could estimate roughly how much of the night had passed, essentially using the night sky itself as a giant rotating clock face. This required serious dedication, clear skies, trained memory, and consistent nightly observation, often as a religious duty tied to temple rituals. Compare that to checking a glowing phone screen in the dark today, instantly, without a single thought. Egyptian priests were essentially running a manual, human-powered timekeeping system, using nothing but memorized star positions and the night sky as their display. But stars and sunlight both depend on clear weather, so was there a backup system too? Here's where Egyptian ingenuity really shows. What if it was cloudy, or you needed to track time indoors, away from both sun and stars? The answer? The water clock, known as a clepsydra. The design was simple, but clever. A container filled with water, marked with level lines on the inside, and a small hole near the bottom, letting water drip out at a steady, predictable rate. As the water level dropped past each mark, a set amount of time had passed. No sunlight needed, no stars needed, just consistent dripping water, monitored patiently. Some temple water clocks were sophisticated enough to account for seasonal changes in daylight length, genuinely advanced engineering for the era. Compare that to a modern kitchen timer or phone alarm, instant and precise. Egyptian water clocks needed refilling, careful calibration, and constant attention. But they solved a problem sundials and star charts simply couldn't, telling time reliably, indoors, regardless of weather or time of day. So far, we've covered hours. But how did Egyptians track something much bigger, an entire year? Their calendar was built around 365 days, divided into 3 seasons of 4 months each, plus 5 extra days added at the end to keep things aligned again. Remarkably, this system stayed accurate enough for centuries, largely because it was tied to something dependable: the annual Nile flood. Egyptian astronomers also noticed that the star Sirius reappeared in the sky at roughly the same time the flood began each year, allowing them to actually predict the flood's arrival in advance, a genuinely valuable skill for planning an entire agricultural season. Compare that to a modern calendar app, silently and automatically tracking leap years and adjusting for us without a single moment of our attention. Egyptians achieved similar long-term accuracy through careful, repeated observation, passed down across generations. No software required,
just patient collective record keeping.
Here's a detail that might genuinely surprise you. The modern 24-hour day traces its roots directly back to ancient Egypt. They divided daylight into 12 hours and nighttime into another 12 hours based on their sun and star observation systems. Notice something interesting, though. Because daylight length changes with the seasons, an Egyptian hour during a long summer day was actually longer than an hour during a short winter night. Time wasn't a fixed universal unit yet. It flexed with the natural world around it. Compare that to today, where an hour is a hard, fixed unit, identical in July and December, measured by atomic clocks accurate to fractions of a second. Egyptians handed us the basic structure, 24 hours, dividing the day in half. But it took thousands of years of refinement afterward to turn that flexible, sun-based idea into the rigid, precise system we rely on now. So, back to where we started. Checking the time today takes half a second and zero thought. Checking the time in ancient Egypt meant watching a shadow, tracking a rising star, monitoring dripping water, or recognizing a season by the Nile itself. Different tools, wildly different effort involved, but the exact same underlying question. Where are we right now in the flow of the day, the night, the year? Egyptians answered that question using nothing but careful observation of the world directly around them, and in doing so, quietly laid the foundation for the very system still ticking on your wrist today. 4,000 years later, we've automated almost all of it. But next time you glance at a clock without thinking twice, it's worth remembering. Someone once had to watch a shadow move across the sand just to invent the idea of an hour in the first place. And if this journey through ancient timekeeping got you curious about what we uncover next, there's a simple way to come along. Just hit subscribe so you don't miss it.